Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Azri. My metric number AN190147. So today I will present about my final year project. Okay. My topic is the effect of aerodynamic characteristic at different velocity for three different helmet design and neck using computational fluid dynamic (CFD) analysis. Okay, I'm supervised by Mr. Muhammad Fuad bin Yasa. Okay, content for this video is about research background, problem statement and objective, scope of study, literature review, methodology, CFD setup, expected outcomes, conclusion, and lastly overall project planning. Okay, for the research background, for the first, we have the study of the analysis of um, different motorcycle fatality by type of injuries. So we have the statistic here. 63% of the fatality happens on the head, 20% for the multiples, 9% for the chest, and 1% for the hips, and lastly 4% for the necks. So in this study, we will focusing on the necks fatality. Okay, and then we have also the study about the whiplash injury happens to the motorcyclist when the high velocity of air at an instant time happen to the head of the motorcyclist. The blast of the wave of air will causing the head movement, the neck movement from the front to the back. Okay, and then we also for the setup of the study, we designing the helmet for the three different type of helmet, the head and also the neck, with also the dimension. Okay, and then the meshing process for the helmet in ANSYS simulation. Okay, next, this background. We have three here helmets: open face helmet, full face helmet, and half face helmet. And also in this picture you can see that the previous study about aerodynamic effect on the helmet for two type of model, which is full face helmet and open face helmet. Okay, so here we have STI classifications, which is one of the standard that used in whiplash injury for the grade 1 until the most fatality, which is grade 4. No physical or upper back signs, mild damage less than 5% of the muscle disruption. Grade 2, neck or upper back musculoskeletal signs, decreased ROM, point tenderness, more extensive damage, 5% to 95% of muscle disruption. And then grade 3, neck or upper back neurological signs, decreased flexors, decreased sensation, decreased strength, complete rupture of a muscle or tendon more than 95%. Grade 4, neck or upper back fracture or dislocation, complete rupture of a muscle or tendon more than 95%. Okay, next, can we move to the problem statement and objective? For the problem statement, for a long time of riding, there will be several aspects of factor that need to be focused on, especially when involving the safety. Other worldwide research have shown that the protective effect of wearing a helmet in minimizing head and neck injuries. Nonetheless, some studies have suggested that wearing a helmet increase the risk of neck injuries. This study will be analyze the effect of the different type of helmet onto the pain on the neck. Okay, and then the objective, we have three objectives. First, to come out with three helmet design according to the standard of helmet in a solid work format, to analyze the effect of the aerodynamic characteristic at different velocity for three different helmet design, and then lastly, to suggest the best helmet design which exert the best stress onto neck. Okay, scope of study. Scope of study, we have 6 scope of study designing. First, designing the helmet according to the SAE Society of Automotive Engineer to suit the Asian market. And second, the aerodynamic characteristic limited to total pressure, velocity, and principle of elastic strain. Third, the static structure analysis limited to the maximum principal elastic strain for different type of element on two major different critical point of helmet of neck and helmet. For the analysis of helmet model using computational fluid dynamic, CFD, and SolidWorks. The analysis of study focusing on the upper body according to SAE standard. The velocity used are 20 meter per second, 25 meter per second, 30 meter per second. Okay, next literature review. So we have 6 literature review. The source, the title, understanding the impact of the physical fatigue and postural comfort experienced during motorcycling. Analysis of upper body ergonomic parameters on commuter bike motorbike users. Tips for performing physical examination of the neck in the whiplash associated disorder. And then fourth, strength and response of the human neck SAE. Biomechanical of whiplash injury. And lastly, numerical analysis of drag coefficient for motorcycle helmet. So this selected uh, selected article that been used in this research have been helping me for completing my final projects. Okay, next methodology. For the methodology, we start by designing the hybrid helmet and the human upper body part using SolidWorks modeling, and then measuring of the model using the ANSYS workbench. We insert the designing model in the SolidWorks into the ANSYS, and then applying the boundary condition and static load, solving the finite model for ANSYS structural. For this, we selected the material for the necks and also for the helmet, and then validation. If no, we coming back to the applying initial boundary condition and static loading, and then rebuild that step. And then if yes, then result discussion, and then repeat the step 1 to 5 for the other helmet, and then conclusion, starting the analysis of each type of helmet safety toward the neck pain. And then CFD setup. So for this study, we use FSI, fluent static structure. So we have two part, fluid flow fluent, which is study of the airflow, and the static structure, the study of the effect of the fluid flow onto the structure integrity, the movement of the neck, and also the effect that causing the neck or the helmet. And then this is some setup, solver setting, type analysis, model setting, and boundary condition. The dimension used 3-dimensional CFD, double precision, processing option, parallel process, solver method. This study will focusing on the pressure base, velocity, formulation absolute, time steady, viscous model K epsilon, which is this study is in laminar process. Okay, K epsilon, inlet velocity. So this is one of the velocity that we use, 30 meter per second. Outlet 0 pressure, and then the helmet must be no slip. So at the bottom of the helmet we use fixed structure in order not, we doesn't want the effect on the lower body part. We always want the the result obtained on the neck and the helmet. So this is some meshing process. So this is actually the great independent test which I used to validate my model for the 3 type of model. So for this great independent test, I only use the full face helmet, which is to determine the element size for 3 element size, 34.36 millimeter, 23 millimeter, and 10 millimeter. So as you can see, the gradient independent test, the most suitable uh, element size is 10 millimeter, because the line is quite consistent with the 23 millimeter element size. So this step is required in order to validate the model, if it can use to get a more accurate result. Okay, next we move to the result and discussion. For the result and discussion, first I have been running the simulation, and the result obtained in pressure, in velocity, the comparison of velocity distribution across the helmet type. So figure above show the difference velocity distribution on 3 type of helmet. This helmet produce different value of velocity at the same point, which at upstream level. The maximum velocity value for full face helmet is 86.13 meter per second, while for open face maximum velocity is 84.39 meter per second. The least velocity value is at half face helmet, which is 76.34 meter per second. As velocity distribution increase, the streamline also increase. The drag force produced will decrease, thus low stress produced. So the point is, when the high velocity happen um, at the helmet, the velocity will causing the streamlines increase, and also the drag force which is opposite direction from the thrust force that happen in the movement of the motorcycle. So the drag force decrease, and thus the stress produced also increase. So next we move to the wake formation. As you can see that this is a 3 type of helmet with different of wake formation at the back of the helmet. So figure above shows the flow pattern over the front and back of the helmet are quite different. In the front, the flow smoothly, which is laminar, uh, but in the wake, flow is usually high, unsteady, and large eddies or vortices are shed downstream. The large eddies are formed at a regular frequency, and they produce pressure disturbance in the flow. Wake formation are more obvious in half face helmet, rather than in the full face helmet and open face helmet. As the wake formation increase, the drag force also increase. The wake formation differ for the full face helmet and open face helmet. For the full face helmet, the formation form on the neck and the helmet, while for the open face helmet, the formation was formed on the helmet only. This can be described that the open face provide less drag force compared to the full face helmet. So basically, the wake formation will affect the drag force also, rather than velocity on the upper streams of the helmet. Okay, and next we move to the pressure distribution of the types of helmet. So first we have full face helmet, open face helmet, and half face helmet. Figure above shows the 3 conditions of an applied value of velocity 20 meter per second, 25 meter per second, and 30 meter per second, affecting on the model pressures. The pressure produced on the model form. Apart from the other models, this model does not consist of visor that can protect the surface of the head, which is for the half face helmet. The flow of the front of the head can be unsteady flow. The pressure point at the front part of the helmet is about to be distributed, scattered, and uniformly. The contour of the light blue forms on the neck of the human model are slightly differ from the model of helmet open face helmet. The light blue contour indicate the low pressure form on the neck are less than in the open face helmet. The velocity of the air at this part are high, thus the pressure will be low. On the other hand, there are formation of the high value of pressure on the front part of the neck. This can affect the movement of the helmet and the neck. So basically, the pressure distribute on the point which is at the different type of helmet is ununiformly. So for the full face, the design is not protected by the visor, so that the face of the head are affected by the flow of the air. Thus, the pressure on the front part of the head are produced ununiformly. Next, maximum principal elastic strain. Table shows the value of the minimum and maximum elastic strain formation on the helmet and the neck of the model. So this value are done by applying the pressure of air to the model. Pressure and velocity of the inlet air that flow through the model gives such a difference in the unit values of the elastic strain form. Full face helmet from this result shows the least value elastic strain compared to the other model. This happens because of the design of the helmet are far less complexity, and stagnation point formed on the front part of the helmet are producing even split of the air. The formation of the turbulence flow on the backs of the helmet are also less. According to the theory, maximum principal elastic strain, the failure of the material or component will occur when the maximum value of principal strain develop in the body exceeding the limit value of the strain. So for the conclusion, they summarize the aerodynamic force including the velocity and pressure distribution uh, that affect at different type of model, causing a significant large due to the design of the helmet itself. The study suggests that the use of full face helmet meet the most safest criteria compared to the other design in terms of neck pain. The future of the study should be more concerned on the analysis the prolonged use that could causing more fatality. Okay, and then the conclusion. For the conclusion in this study, computational fluid dynamic analysis using one-way coupling of the fluid-solid interaction approach. This method typically describe the pure mapping of physical properties resulting from the analysis of fluid model to another solid model. This study examined the effect of airflow on the different type of helmet and neck pain. The analysis of the total deformations, maximum elastic strain, and the maximum principal stress are shown in various velocity of air affecting the human neck. Different type of helmets design exhibit different value of the fluid flow of air, and then the other parameter which could also affecting the integrity of the structure. This can be examined through the flow condition and the structure analysis in the static structure simulation. As the result, the finding of this simulation required more detailed perspective in doing the research, which could lead to more accurate result. These predictions are thought to be help solving problem not only in the matter of engineering but also for the public safety and health. Okay, overall project. This is the overall projects for uh, this study. Okay, thank you for your attention.